This is Carsten OZ9 Alpha Alpha Radio with a demo of my program of my application SimpleCalc, which among other things can measure the 3 dB beam width of an antenna, and can also measure the sun noise that you receive in your system. For more information, you can visit my webpage www.moonbounce.dk. I start by showing you the SimpleCalc main application, the main window, and on the webpage you can find information how to install and where to find the application. First of all, I go into the measure noise window. Currently, I'm receiving noise from my 4.8 meter dish. I have a web camera here with a live view from the antenna. It's located outside in my backyard. It's currently running on 23 centimeters. The dish is 4.8 meter diameter, and right now it's pointing up in cold sky to establish the cold sky level where there is no noise. If we look at the level here, this is the data from the radio at the moment. If I right-click on the track, I can set the cold sky marker to this level. Let me adjust it just a little bit. Here we have it. This is the cold sky with my setup around minus 61 dB. One thing that is very important is when you measure sun noise and generally measuring the output from the radio, it's very important that you disable the AGC and that your radio is the receive chain is completely linear. If it's not linear, you can't measure it accurately. Again, look at the web page of SimpleCalc. There are some explanations there what you need to take care of. So right now I have my dish pointed at cold sky, as I said. This is my rotor controller. You can see that the sun is around azimuth 176, elevation 55, and the antenna is pointing at 150, so around 26 degrees offset. In my rotor controller here, I can configure it so that it only tracks on elevation, which is what we need for this test. What I will do is that in a short moment I will move the antenna in azimuth some 10 degrees or more ahead of the sun. So I will probably move it up to azimuth 190, and then I will let the dish azimuth be parked there, and the elevation of the dish will follow the sun. This has the effect that while the sun is moving across the dish will follow the sun's elevation, so that the sun will come in from the side of the dish and leave it on the other side with the correct elevation all the time. Right now, as I said, we have cold sky. One thing I usually do is I do a check where I disable, or not disable, but where I switch the input of the LNA from the feed horn into a 50 ohm terminating resistor. And this is what you see right now. And we can switch it off again. So now we are back with the LNA into the feed horn. And if I place a delta marker from cold sky, you can see that I have around 7.3 dB difference between a cold sky and terminating resistor with the setup I have right now. I have to add that when I measure sun noise in my setup, I have extra attenuation between the LNA and the radio. Otherwise, the radio goes into saturation, and I can't measure the sun noise reliable. So this is basically the baseline. We are getting data in from the radio all the time. So what I will do now is that I will move the antenna from up to, let's say, the sun is 177. I will move the antenna up to 190 in azimuth. Okay, so now shortly you will see the noise picking up here while the antenna moves past the sun. Yeah, it takes a while. It's not the fastest antenna. You can see now the noise picks up. This is not something we need to take care of. It's just a side effect of doing this because we are sweeping. You see, we just passed the sun at azimuth 178. So now we are almost at the destination 190. Yeah, and there we are. So now you will see that the noise goes down again. And we're not gonna hit the cold sky in this at that point because we have we're not far away enough from the sun that we are still picking up some noise. So what I do now is that I will activate tracking of the sun, but it's important that it's only the elevation that will follow the sun. The azimuth is fixed at 190 degrees. So right now the sun is approximately 11 degrees east of the antenna, and within what is it, half an hour, 45 minutes, it should be at the peak, and I will pause the video until then, and I will get back once the sun has moved a bit closer to the dish. So be back in a few minutes. So back again, just to show how far we have come. The antenna is still about 4.7 degrees in front of the sun, so we are still waiting for the sun to catch up, and you can see the noise is starting to increase. The small bump we have here is the side lobe from the antenna. We can see that more clearly once we have all the data. But this was just to show that the process is still going. So I'll be back again in a few minutes. So you can see now that the sun has passed the antenna. Sun is currently at 190.7, and antenna is still parked at 190 degrees. So sun is about 0.8 degrees ahead of the dish now, and you can see we had the peak around here. We can right click and we can place a delta marker from cold sky, and we can see that the current sun noise is about 16.65 dB with the cold sky level that we set. We can also, if we place a reference marker here, we can go to the side lobe and we can place a delta marker from the reference, and you can see it's minus 14.35 dB down. And the angle, the sun was at at 190 degrees at that time, and here it was 181, so about 9 degrees. Maybe this is not quite correct. I think this one is more correct. So about 10 degrees, 10 degrees out, we see the side lobe. Now we'll just wait for the sun to pass even more away from the antenna. Around when the sun is about azimuth 200 or so, I will get back, and then you can see the complete sweep, and we can generate the 3 dB beamwidth report and stuff like that. But yeah, also another thing maybe worth mentioning is that this is my rotor controller. It has a built-in web server, and on this you can see this is the current load for the axis, and the azimuth is obviously not drawing any current because it's stationary. It's parked in azimuth, and the elevation is only very seldom. And now you saw it actually moving, but as we're measuring around the azimuth 180 of the sun, the elevation, the change in elevation is very small, and it has as we are looking at the sun at its peak elevation, so change in elevation is not much. It's less than a half degree from when we started. I think it has moved. So that was just a comment, and this leads me to that. If you're going to do this measurement yourself, and you don't have the ability to track the sun only in elevation, it doesn't matter much if you do the test at transit when the sun is passing south azimuth 180, as the sun's elevation is not changing a lot. So you might get on with just parking the dish at azimuth 180, and at the maximum height the sun will be at 180 degrees, and then just let the sun drift by. If you can get the antenna to track in elevation, it will be the best, because you have the most clean sweep. Then the sun is passing the antenna right from the side and leaving it at the other side without any change in elevation, as the dish is following the sun's elevation. So I will wait approximately 7 degrees more, and then I will resume, and then we can do some more measuring, and I can show you the markers and so on, what they can do. So back in a few minutes. So I'm back again. The sun has now drifted approximately 10 degrees more further away from the antenna. So the sun has now moved 20 degrees in total in azimuth. And if we look at the web or the camera, I'm not sure if you can see it, but yeah, you can see the shadow is now here from the feed horn. This is because the sun is now moved further to the west. Let's get back to the noise view. Just to remind what we're seeing, first here was cold sky. We were pointing up in at cold sky. Then I checked. I connected a 50 ohm terminator on the input of the LNA instead of the feed horn, and measured the delta 7.3 excuse me, 7.3 decibels. Oh, and one moment. So back again, sorry. 7.3 dB from cold sky to 50 ohm terminator. And then we started moving the dish 10 degrees ahead of the sun in azimuth. And the spike we see here was when we passed the sun's azimuth. We saw a brief peak here. And then the dish was parked in azimuth, and we saw the first side lobe. And as the sun moved, the sun noise increased until we reached the peak up here. And the sun kept moving away from the dish and all the way down, and we saw the other side lobe out here. And the noise is still dropping, but eventually, after some time, it will go down again to the cold sky level we see here. Now there are different things we can do here. Manually, we can go up and we can place a delta marker that shows the delta from the cold sky level to the level we have here, which is in this case is 16.61 dB. And we saw that when the sun was at 190 azimuth, and that was while we had the dishes parked at 190. So from this we can see that the azimuth points correctly on the dish. It was exactly there we saw the peak. We have the delta of plus 16.61. We also have the side lobes, which I showed you before. We can place delta markers on those two, and you can see that from the 190, it's about 8.8 degrees out. And the other one was 8.8 degrees out also. And there is, you can see they are 2.22 dB above cold sky and 2.44 dB above cold sky. So if we clear those two, just click on them, we just clear these. And then we, hold on, when I point up here, place a reference marker, I can go out here and I can say here, place a delta marker from reference, and I can do the same over here. Then you see that this one is now the reference. So you see the side lobe here is 14.39 dB below, and this one is 14.15 dB below the reference, which was this one. So this is different ways of applying the markers. You can do all kinds of markers. You can add different. You can user-defined text and so on. A lot of things you can do here. You can try and play with that yourself. So a new thing in SimpleCalc is this half power beamwidth, where you can have the program analyze the sun noise and find the 3 dB and the 10 dB points. You can drift scan the sun in two ways. You can either have it done in azimuth or in elevation, and this is also explained on the web page. But what we did here was that the sun passed the dish in elevation or in azimuth. Sorry. So we select the top one here, and you get a warning that, remember, you need to find a cold sky for this to work correctly. But we already established cold sky, and there you have it. This is an completely automated function. I search the curve for the peak, and then I I go out to the left and right and find the 3 dB drops. The left one is at minus 1.57 and the right one is at plus 1.59. So this is the 3 dB points, and the 10 dB points are at minus 2.78 and plus 2.81, so very symmetric, as you can see. And this is a message box that comes up, explains what we did, the hard facts, cold sky level, peak level, the sun noise we measured 16.66 dB, and the left and right 3 dB points are at those angles, and the half power beam width is 3.11 degrees, and this is estimation of the gain, and normally you would pick the one in the center here at 65% efficiency of the feed horn, which gives 34.5 dBi. Smaller dishes of 1.5, maybe 1.8 meters, you will probably end up around 50% efficiency, depending on the feed horn, because you have a lot of blockage. But it depends a lot on the feed horn, of course. The minus 10 dB beam width is at 2.78 and 2.81, and the ratio between the two are 1.77. So this is just a quick summary, and if I say OK to this, the application asks me if I want to generate a PDF file of the results, and I can say yes to this. Yeah, I won't add any comments here. Yeah, I can make this one include comments, and now we have a report, and let me pull that one up here. One moment. You see, this is let me see. It's maybe not easy to read. Yeah, you can see it. This is the generated PDF file. You see the basic information of what was done, azimuth drift scan. You see the raw data as we saw before, and I also selected that it should include the data from the main page of SimpleCalc. I'm not going to touch this in this video, but SimpleCalc can predict the expected sun noise you should measure if you enter all the variables, noise figures, losses, and so on, and the correct solar flux if you fetch that. That's not available right now from San Vito in Italy for me, so I'm using old flux data from yesterday. But basically, it's all the details from that page that are included down here. And here you get a zoomed view of the trace with the markers, and if you print this out, you can easily read it. It's not so that it is impossible to read or anything. It's just because the screen here is not that high resolution. So yeah, it's this is it. So this is the report, and this is pretty much it. I hope it made some sense, and have a look on the web page for SimpleCalc, and you can find more examples and explanations, and you can download the program for free, of course. That's it. Thanks for watching. 7 trees, and see you later. Bye bye.